Hey everybody, Brian Garcia, meteorologist, National Weather Service, San Francisco Bay Area, Monterey Bay regions. We are here today to do a deep dive into the winter outlook. So this isn't going to be your typical 2, 3, 4 minute video. It's going to be a longer, extended video to really get into some of the minutia and nitty gritty about the upcoming winter. So have a seat, grab your water, grab your coffee, whatever you need, and let's get down to it. So here is what we're going to take a look at. We're going to recap last winter, so just a brief look back at what happened last winter. We're going to talk about the current drought monitor as well as the outlook. We're going to talk a lot about El Nino Southern Oscillation, otherwise known as ENSO. That's kind of the overall name, and we'll get into that. We'll get into the outlook, and then we'll talk about some other winter threats as well as resources. So to really kick it off here, the 22-23 recap. If you lived in the Bay Area during the winter of 2022-2023, you know we just got absolutely lit up with rain. And if you look at this map here, our service area for our office is pretty much the entire Bay Area, all the way down through Monterey County. And so in the southern end of our service area, Monterey County, they had upwards of 200, 300, 400% of normal precipitation during this last water year. And water years are defined as October 1 through September 30. So that's a water year. So whenever you hear somebody say, hey, what's normal for this water year, that's what we're talking about. So if you go north of the Golden Gate or Bay Bridge, you see that it really starts to drop off. You start to see those greens and yellows. So they, up in North Bay, you really only got about 100, maybe 150% of normal, whereas south of the Bay Bridge, you really ended up 150 upwards to 2, 3, 400% of normal. So it was a very, very wet year. Where are we now in terms of drought, and where were we? Well, look at that left graph there. That came out October 17th, so just a few days ago. This video was made on October 20th. So on October 17th, the drought for the state of California is pretty much non-existent thanks to last winter, as well as Hurricane Hillary and that tropical storm Hillary when it came into California, dumping a lot of rain in Southern California. So we've pretty much wiped drought out of California. There's just a couple abnormally dry pockets still. And what a difference a year makes, because you go back a year, October 18th of 2022, you can see that we had areas of exceptional drought in California, all the way down to just that little sliver of abnormally dry up in Del Norte County up in far northwest California. So it's really amazing that we dug ourselves out of, well, we didn't dig ourselves out of, that the environment dug us out of a drought in just one wet season. It's really impressive. So where are we going for this next wet season? This map was released on October 19th and is valid right on through the end of January. And you can see California is just blank there. And that blank just really means no drought. So we don't expect drought to improve because there's nothing to improve. And we don't expect drought to worsen because, well, spoiler alert, looks like we're going to get some rain. So what do we look at for these winter outlooks? And what we really look at is a lot of times we look at El Nino. And it's El Nino Southern Oscillation is kind of the broader moniker for the warming and cooling of the sea surface temperatures across the equatorial Pacific. So we'll start with the upper right there. So in the upper right, you'll see these La Nina conditions here. And La Nina is effectively means that the trade winds have increased and pushed the water, that warm water, really up against the western part of the Pacific. So think of Indonesia and Southeast Asia and those areas. And that warm water also takes the convection with it. So you see the cloud over the warm water there. That's the convection that goes right along with it. In normal conditions, everything just kind of balances out. We have warm waters out to about the central Pacific there, and then it really starts to cool off as we get over towards the eastern Pacific up against South America, and we have a little bit of upwelling keeping those waters cool up against South America. In El Nino conditions, what happens is those trade winds really die off, and it allows that warm water from the western part of the equatorial Pacific to slop over towards the eastern part of the equatorial Pacific. So get warmer waters up against South America, and it really shuts down any sort of upwelling of that cool subsurface water there. So what does that look like in practice? Well, the bottom left graph here, you can see this is just sea surface temperatures, just plain old sea surface temperatures as of October 12th. And you can see all the reds and oranges out up across the western part of the equatorial Pacific here, and then out over the eastern part of the equatorial Pacific. It's, you got some blues down off of Chile, and you get up towards Peru and Ecuador, and you start getting some of those greens and yellows. So it's still cooler, but it's definitely not as cool as it should be. It should be more blues up in this area. But we like to look at sea surface temperatures compared to what normal is. And when we do that, it's called an anomaly. So we look at the anomalies. That means how different is it from normal? And the anomaly map is down here on the bottom right. And you can see across the area that we look at for the El Nino pattern setting up is really kind of in this range here, if you can see my mouse cursor moving there. And that is warmer than normal by several degrees, as a matter of fact. And if you go farther out over towards the Galapagos Islands, you can see that it is extremely warm. We're talking 3, 4, 5 degrees above normal. Even earlier in this fall, right up against South America there, it was 5, 6, 7 degrees Celsius warmer than what it should be. So we are definitely in El Nino. We have an El Nino Advisory currently issued by our Climate Prediction Center, and it looks like we're going to stay in El Nino. So let me describe this graph just briefly here. So you can see 3 different zones, and those 3 different zones, this bottom zone is La Nina, kind of that bluish zone. This greenish zone is our El Nino Southern Oscillation neutral phase, and then this reddish zone is where we're getting into El Nino. And so along this vertical axis here, you can see that we're looking at the El Nino 3.4 sea surface temperature anomalies. So think of that chart on the bottom right, those anomalies, that's what we're looking at. Anytime that we have an anomaly that goes above 0.5 degrees C or below minus 0.5 degrees C, we're in El Nino or La Nina, respectively. In this case, we see that the observation from July, August, September, the July, August, September observation here is already about 1.25 degrees C above normal. So already in El Nino. And then the September observation is about 1.5 degrees anomaly. So remaining in El Nino. Then going out to the right here on the horizontal axis, these are in 3-month segments. So if you look down here at the bottom, it says SON. That's September, October, November, then October, November, December, and so on and so forth, right on through June, July, August at the end here. And we can see the models run continue to go up. So if you just kind of blur your eyes and watch these models, they continue to go up right on into midwinter before they really start to come back down. But even as they come back down, we remain in El Nino conditions right on into April, May, June, July, something like that. So it looks like we're going to remain in El Nino right on into spring, with the peak strength of El Nino happening over the winter months. Now, we'll get into what that means for our area, but just looking at this from a 40,000 foot view, this could be a very strong El Nino, and strong El Ninos are defined as 1.5 degrees C above normal. And this could be end up being a whopper of an El Nino, and it'll be really interesting to ultimately see how it plays out. So why do El Ninos matter? Well, the El Nino Southern Oscillation, when it goes into the El Nino pattern, what happens is that we can typically see an extended Pacific jet stream down across the southern part of the U.S. So this is going to be really interesting to see how this ultimately plays out. And then the polar jet will typically drop out of like the Hudson Bay area, and we'll get a Hudson Bay low set up over there, and it'll really impact across the Northeast. But out over here in California, our neck of the woods, you can see that this graphic typically paints the southern part of the state as wetter than normal. And then in between there, so Central California right up on through Northern California, can be somewhat of a fulcrum area. So it can go either way depending upon how that Pacific jet wobbles during the season. And then we have this area of low pressure out over the North Pacific. And this is going to be interesting, and we'll talk about that a little bit later as well. So not all El Nino events are created equal. Every one of them is just a little bit different. And so this is a chart developed by a colleague down in Tucson that shows the precipitation distribution across the West in weak, moderate, and strong El Ninos. So for those of you who've lived in the Bay Area for a long time, you probably remember the 82-83 El Nino. We hear a lot of stories about that one, as well as the 97-98 El Nino. And if we look at the chart right across the top here, all the strong ones, and we go 82-83, there's a lot of green across California. That's a very wet winter, definitely above normal. And you can see precipitation percent of normal at the bottom of that chart there. When it gets deep into the greens, we're 150, 200% of normal, and that was 82-83. Then we go to 97-98, and the same thing happened. It looks like even worse. But you look at the other years, going back to 57-58, just a little bit green across the Bay Area, 65, 66. That's brown. That's drier than normal. 72, 73, a little wetter than normal. 91, 92, well, drier, really. It kind of hung down in the southern part of the state. And then 09 into 2010, a little bit drier around the Bay Area. And then the one that I think a lot of people forget is 2015 into 2016. That water year ended up drier than normal, and it was a whopper of an El Nino. As a matter of fact, somebody down at NASA in Pasadena called it the Godzilla El Nino, and it got everybody just riled up. And we had Super Bowl 50 hosted in Santa Clara that year in January of 2016, and it ended up being sunny, beautiful, probably in the mid-70s if I remember right, for the Super Bowl. And we were drier in a big El Nino event. So just because we are saying that this could potentially be a major El Nino event, it doesn't mean that we're going to get absolutely obliterated with precipitation. So this is something we're going to have to watch through the season. So let's go in and look at the outlooks for both November, and then we'll go into the seasonal outlooks. So on the left, as we go through this, you're going to see the temperature outlook. In this case, it's monthly for November, and on the right, you'll see the precipitation outlook. You'll see above, you'll see below, you'll see equal chances. And what that means is you have a probability, like on the left graph, for example, you see above normal for temperature. That means you have a higher probability of being above normal for temperature in the month of November. Doesn't mean there won't be cold spells in November. No, it just means when it's all averaged out and said and done for the month of November, it means that we will likely be warmer than normal for the month of November. On the right, you see equal chances. Equal chances is always hysterical for me because it is essentially the meteorological equivalent of a shrug. It's kind of like, we really don't know. There are no clear signals one way or another that it could be drier or wetter, or the odds of being drier or wetter are higher in either of those. It just simply means equal chances. Below, above, or near normal all have equal chances of occurring. So that's November. Now we're going to look at the seasonal time frames, because when we talk about climatology, we talk about it in seasons. So it's 3-month chunks. And so here we're going to look at November, December, and January. You can see the temperatures here on the left. We have a higher probability of being above normal for this 3-month chunk. In precipitation land, equal chances, again, that meteorological equivalent of a shrug. There's no clear signal of one way or another. But you can see across the southeast portion of the U.S. that the probability is high to be above normal for precipitation. And that goes right along with that graph of the normal, the typical El Nino type pattern. So it looks like the pattern, at least in the early part of the winter, is going to cut across northern Mexico into the southeast part of the U.S. Now we're getting into December, January, February. These are our core wet months. Temperature-wise, it looks like we have a higher probability of being above normal for precipitation, which stands to reason because the sea surface temperatures have been very warm globally. It's going to take a while for those to cool back down, so it makes sense that we'll just remain a little bit on the warmer side. Does it mean we won't have cold snaps? Absolutely not. We will have some cold snaps. We will have some systems move through that usher in colder temperatures. Whether it's frosty or downright freezing will yet to be seen, but we definitely will have some colder temperatures simply because it's winter and we have very short days and we have a lot of time to radiate out any heat that's being imparted to the earth during the daytime. On the right graphic there, you see seasonal precipitation for December, January, February. So again, core wet months, and look at that. We have a higher probability of being above normal for precipitation in that 3-month period. And these graphics just came out on October 19th from the Climate Prediction Center. So this is something we really have to start paying attention to and see when the rain is actually going to, when this pattern, I should say, is actually going to shift into this mode that it could potentially be bringing us these above normal values for precipitation. So right now, like we saw in November, equal chances for November, and then November, December, January, equal chances. So knowing that it's equal chances for November, December, January, and then it goes above for December, January, February, it tells me that it's probably going to be backloaded on this time frame. So more January, February, even February time frame for being above normal. But again, that's something we're really going to have to watch closely. As we get into January, February, March, again, temperatures, higher probability of being above normal when everything's said and done and averaged out over that time frame. And then for precipitation, we're looking at it being a higher probability of being above normal for precipitation as well during that time frame. So we could end up with a wet late winter, early spring type scenario. Moving into February, March, April, temperatures, higher probability of being above normal for temperature, and for precipitation, we drop back into those equal chances. So again, there's no clear signal at this point, but if you look up in the northwest, it's below, and that is, it looks like it's creeping southward a little bit, or at least westward from the last few graphics. It's trying to move out towards the west, but equal chances regardless for our area from February, March, April for precipitation. Then as we get solid into springtime, March, April, May, the temperatures, that probability of being above normal starts to creep north. Well, that's probably because we're already warming up for that time of year. So this is when the days start getting longer, we start warming up, things start blooming. It's just, we start to become more normalized at that point in time. And then for March, April, May, in terms of precipitation, equal chances. Again, this time of year, the precipitation normals really start to tank off anyway. So equal chances. It doesn't mean we can't see a miracle March or an amazing April or marvelous May, but there's just no clear signal right now in terms of precipitation outlook for that time frame. So that's the outlook. What are some other winter threats that we really have to think about? This picture that I pulled off of the California Coastal Commission's King Tides page. This is flooded on-ramp and off-ramp from Highway 101 northbound in Sausalito. When the tides get high, it floods very low-lying areas around our region. And so this is going to be really interesting this year for me, being somebody who likes to be out in the marine environment, because we're going to have the big tide swings come again around Christmas time and then again in early to mid-January. And with the ocean temperatures as warm as they have been, if we continue to remain warm, we have thermal expansion. That means the water levels will be a little bit higher just because it's just a little bit warmer. And if we get areas of low pressure moving over our areas, that means the water can actually raise up a little bit because there won't be so much atmosphere pushing down upon it. So going to be very interesting, but something we're going to have to watch. And we'll have to watch for the swells as well to see how those impact areas. But tides matter, and tides play a role into people walking on beaches as well as our marine traffic that goes in and out of San Francisco Bay. So a lot of different issues with big tides. And speaking of coastal areas and coastal flooding and coastal erosion, big surf is a problem. We just saw that with this last couple days, the 18th and 19th. We had some really, really powerful surf move into the area. This picture is from last year, from January of 2023. But big surf can batter the coast. Coastal erosion can cut off access to people. It can also wash up into very low-lying areas. In Santa Cruz County, we saw the town of Capitola, the village down there, get flooded and really just kind of wrecked by some big surf on top of those high tides. So if we get some king tides and we put big swell on it, we have big issues. So this is, again, is something that we watch through the winter, and we try to make sure that we get our partners as well as the public ahead of it with any sort of knowledge of things coming up. Coastal flooding, again, plays right into this. So we got king tides, we got big surf, and coastal flooding. This is down at Rio Del Mar in Santa Cruz County. Low-lying areas near lagoons, bays, and open ocean are at greatest risk. So coastal flooding can be a problem within the bay during king tides, as well as if we have any tidal anomaly on top of that. So high tides can exacerbate this issue, of course, as well as high surf and storm surge. Then the really interesting part to me always is if we get excessive rainfall and we have a high tide coming in to a river mouth, it can actually cause a deformation zone where the drainage is trying to drain out all of the rainwater coming out of the river or creek or stream or whatever it is, and the ocean can be pushing in on that, so it might not let it out, so it can cause some kind of flooding around the mouth of the of any sort of river, creek, or stream. Some resources to be aware of: weather.gov/Bay Area. That's our homepage. So go visit it, go bookmark it. There is so much stuff on there, it's ridiculous. I would love to take you all through everything that we do there, but it would take forever to go through all the things that are on there. But go poke around. My favorite spot is under current conditions and observations. Right there you can watch the observations with any given system that's coming through the area, from wind to pressure to rainfall. It's really fascinating to watch as things come through. If you haven't followed us on social media, and you're probably seeing this linked on social media, we're on Facebook, Twitter, X, and YouTube. At NWS Bay Area is our handle, and we post a lot of stuff there through the winter, especially when we're in storm watch. We're trying to constantly post up there so that everybody can have the latest up-to-date information as we are impacted by winter storms. At the end of the day, though, it's really important to be ready for anything. Like we saw, this can be a whopper of an El Nino, and it can also be a dry El Nino like 2015-16. Last year was La Nina going into a neutral phase, and we got absolutely hammered by the precipitation that came across our area. So just because it's El Nino, La Nina, or neutral doesn't mean that we should let our guard down or be on the highest possible alert. If anything, we need to always be vigilant and always be prepared and always have our resources ready and available to get information into us so that we can take action in order to protect ourselves, our family, and our loved ones. So that is it for the winter season outlook. Thank you for taking the time to watch this. Most of all this winter, please be good to yourselves, be good to each other, and be kind to one another. Take care, everybody. See ya. Bye.